Download this code from codegive.com, link in the description below. Setting up an object detection inference server on a Jetson Nano is a great way to leverage the power of Edge AI for real-time applications. In this tutorial, we'll go through the steps to set up an inference server that uses tensorrt-optimized models for object detection. We'll utilize Flask as our server framework to handle incoming requests and return predictions. Prerequisites: 1. Jetson Nano. Ensure you have a Jetson Nano set up with Jetpack installed. Jetpack comes with the necessary libraries like tensorrt, cuda, and others. 2. Python. Make sure Python, preferably Python 3.x, is installed. 3. Flask. Install Flask using pip. Bash. Pip install Flask. 4. Deep learning framework. You can use TensorFlow, PyTorch, or any other deep learning framework. Here, we will focus on using TensorFlow for the object detection model. 5. Model. Download a pre-trained TensorFlow object detection model. You can find models on the TensorFlow Model Zoo, https://tensorflow.org/lite/models/object_detection/overview. For this example, we'll use the SSD MobileNet model. Step 1. Set up the object detection model. 1. Download the model. Bash. Bookit http://download.tensorflow.org/mobilenet_v2_coco_2018_coco_29.tar.gz tar xvfssd_mobilenet_v2_coco_2018_03_29.tar.gz 2. Convert to TensorRT, optional, for performance improvement. Conversion to TensorRT can be done using TensorRT APIs or by using the tf.experimental.tensorRT module if you are using TensorFlow. The conversion process is beyond the scope of this tutorial, so we will assume you are using the TensorFlow model directly for now. Step 2. Create the inference server. 1. Directory structure. Create a directory for your project. Bash. mkdir jetson_inference_server. cd jetson_inference_server. 2. Create a Python script. Create a new Python file named inference_server.py. Python. From Flask import Flask, request, JSON IFA. Import TensorFlow as TF. Import NumPy as NP. Import CV2. Load the model. Model equals tf.saved_model.load, ssd_mobilenet_v2_coco/saved_model. Initialize Flask app. App equals Flask, __name__. Utility function to run inference. Def run_inference, image. Input_tensor equals tf.convert_to_tensor, image. Input_tensor equals input_tensor tf.nwaxis. Detections equals model, input_tensor. Return detections. At approot, /detect, methods equals post. Def detect. Get the image from the request. File equals request.files image. np_image equals np.fromBuffer, file.read, np.uintdate. Image equals cv2.imdecode, np_image, cv2.imread_color. Run inference. Detections equals run_inference, image. Prepare response. Response equals detection_boxes, detections detection_boxes.numpy.tallest. Detection_scores, detections detection_scores.numpy.tallest. detection underscore classes, detections detection underscore classes dot numpy, dot tallest. Return JSON if, response. If underscore underscore name underscore underscore equals underscore underscore main underscore underscore. App run, host equals 0.0.0.0, port equals 5000. Step 3, running the server. 1. Run the server. Bash. Python inference underscore server.py. The server will start on http://jetson underscore nano underscore IP 5000. Step 4, testing the inference server. You can test the server using curl or postman. Here's how to do it using curl. 1. Prepare an image for testing. Save it as test.jpg. 2. Use the following command to send an image for detection. Bash. curl x post f image equals at test.jpg http://jetson underscore nano underscore IP 5000 detect. Step 5, interpreting the response. The response will contain the detection boxes, scores, and classes in JSON format. You can use this information to visualize detections or use them in your applications. Additional notes. Performance. For better performance, consider converting your model to TensorRT and optimizing it specifically for the Jetson Nano. Security. This server is for local testing. For production use, consider implementing authentication and validation mechanisms. Further improvements. You can extend this server to handle video streams, save results, or integrate with other services. Conclusion. You now have a basic inference server set up on your Jetson Nano for object detection using a TensorFlow model. You can expand on this foundation for various applications in computer vision and AI. Happy coding!